Nice background. All right. Hey, it worked first time. That's awesome. Well, first of all, thanks everyone for coming over. It's really awesome to see so many faces today here. Great turnout. Great. Probably means that we will be doing a second meetup, hopefully. All right, so today we're here to talk about Apache Cassandra CDC and how that feature is going to look like. First of all, let me introduce myself. Name is Bernardo Botella. I work for Apple. I work for Apple 4 years at this point, and became a committer recently this year, an Apache Cassandra committer. Been working on a bunch of different features for Cassandra here and there on the different sub-projects, including the Cassandra itself, the sidecar analytics. And I think the biggest contribution that I've made is that CP42, which stands for the Apache, for the constraints framework for the CQL language. That it's actually related to this CDC. At least CDC was the source of that idea. So yeah, without further ado, what's CDC? CDC stands for Change Data Capture. And it's basically a way of publishing from a data store, from a database. It's a way of publishing everything that changes on a database. So every single mutation will generate an event and will be pushed to a downstream service through a transport layer. That's what it is. Now that enables a bunch of different use cases. Real-time analytics is something that suddenly becomes possible with that because you can just keep aggregating stuff, for example. Stream processing with Apache Flink, for example, is another good example of things that are being enabled by this feature. Notifications, it's also something that we have heard from customers that they're really interested about. So basically being able to notify when something has changed, when something has been updated, when something has been deleted, and of course cache managing, being able to invalidate a cache when a key changes, or populate a cache, or keeping it fresh and synchronized. So with Change Data Capture, the main goal that we had when designing and implementing this is that it has to follow the same principles as Cassandra. It needs to be scalable, petabyte scale, all the good things that Cassandra provides need to be respected by CDC feature. Same thing for consistency. You need to deduplicate, just publish events when quorums or read quorums are met, which means that write was successful. Deliver at least one, so no mutations are lost on translation. It has to be highly available. It needs to support schema changes as well, because schemas can be updated, and CDC needs to be able to deal with that. And same thing for cluster operations. So it needs to support when a cluster is expanded, clusters rings, when you deprecate a node or when you change a node. All of those operations should be transparent to the downstream consumer of that CDC stream. Now, in order to build this, let's make a little refresh of how CDC works for Cassandra. So CDC is a feature that has been implemented inside Cassandra for a while. And the way it works is that it has a commit log. A commit log is basically your binary file that you just append every single mutation that comes to a node, you append it to that log and call it a day. And that's how CDC works for Cassandra. That's the actual basis of it. Now, that feature was written several years ago and was introduced in that Cassandra 8.844 JIRA. It is enabled on a per table basis. And yeah, CDC raw is where that commit log is stored. And that's about it. That's what CDC was up until the CB44. Now, the cool thing about that that approach for CDC inside Cassandra is that it's low impact. Basically, you're not in the middle of the right path. Just every mutation, just shove it to the commit log and call it a day. Therefore, it's high performance. It goes to It's also durable because that file is an actual file on the hard disk. So it supports, or it's resilient to no restarts and stuff like that. It's also low latency because, as I mentioned before, it's not part of the write path, and it's scalable because you want more commit logs, just add more nodes, just like Cassandra. But of course, it comes with a bunch of limitations. That needs to be decoded because, as I mentioned before, it's a binary file. And those formats also change with Cassandra versions, and that becomes messy really fast. Consistency becomes really tricky. Like when do you emit an event? Is it when one node gets the mutation? When several of them do? You need to respect the quorum or the read quorum that Cassandra is configured for. And yeah, there's definitely no handling of cluster operations. If you shrink the cluster, some of those commit logs will get lost. If you expand it, some of those commit logs will be empty. That also becomes messy. Now, in terms of publishing, there's no way of directly publishing whatever you read from the commit log on the Cassandra node to anywhere. And yeah, it's also hard to keep track. Like, let's say you restart a node. Where was I? Like, what's the latest event that you posted to the transport layer? Where should I pick up from? And that's our current solution for CDC. Now, I also want to talk a little bit about Sidecar because that's a core component to the CDC solution that I'm presenting today. So what Cassandra Sidecar is a process that will run alongside your Cassandra node that provides a layer of it provides a lot of things. Actually, it does a lot of things, but it's mostly you can imagine it as your control plane process. It gives you a bunch of APIs to do stuff with the Cassandra node, to extract information from there, to stream files from it. It has direct access to the database and kind of query stuff. And yeah, if you're curious, that it's an official Apache Cassandra subproject as well, just go and check it out. So that's where we wanted to add this solution to. CP44 is the document that we wrote and had approved by the community to implement that feature. And basically what it's doing is like all of those limitations that we spoke about before, it's trying to shove them into the sidecar. So sidecar will take care of handling or retrieving the commit logs from the Cassandra nodes, parsing them, deduplicating them, making sure that the quorum is met, and publishing them to whatever transport layer we choose. The initial implementation will support Kafka, but that's basically an interface. Just pick your own poison and implement the interface. And this is how it will look like. I'm gonna be a little bit fast. I hope it's at least readable. But yeah, I want to be a little bit faster on this slide because I have a quick demo at the end. Hopefully nothing will break. But yeah, basically, as you can see there, you have your Cassandra cluster with a sidecar. Sidecar will keep reading from the nodes that it owns, and the ownership is in terms of the actual token range. So every single sidecar involved in this CDC process will own a part of the token ring, and it will keep pulling the segments from those Cassandra nodes. Once they have been pulled, just to duplicate, as I mentioned before, make sure that the quorum is met, and if that's the case, then serialize the event into Abra format, show it to Kafka, and push the Abra schema that you used to serialize the event to a schema registry. Now, that will allow customers to completely decouple from the database and just read that message from Kafka using the same schema registry. And yeah, another problem that we mentioned, another limitation that we mentioned is the state persistence. So what happens if one of the sidecar gets restarted? The way we have solved that is that given that sidecar has direct access to Cassandra database, it has a special table containing that state. So basically, whenever something has been pushed, the state gets updated. So that way, whenever sidecar is restarted, it just reads from the Cassandra database, which is resilient and knows where it needs to pick it from. And yeah, that's mostly it. It also supports topology changes. As I mentioned before, this new feature Those deal with host replacement, those deal with token moves, cluster expansions and strings. So yeah, we have been working with it for a while. We have been testing it, and it's time for a demo. So what I want to demo here, okay, there we go. We all love a terminal, don't we? No, we don't see anything. Right, let me mirror my screen. Demo effect. Right. I can choose. Right. I'll sit down there. No, I don't. I'll do my best. All right, so yeah, the thing is that I don't see the screen.
We can see it.
Yeah, I know, but I don't know what I'm doing because I don't see it here.
Oh, no.
All right, let me try to rearrange this. Oh, and that's my main display. Good. Does it say display somewhere?
You want to duplicate? Is that what you're going for?
Yeah. Does someone know how to do that?
Wait, see if I can figure it out. Be back there.
The main displays.
Thing is that maybe in settings. Oh. This should be easier.
Yeah. We're just give us a second. That's us.
All right.
If you click on extended display, it should give you an option to actually do it as well. Use as from
Top right.
up.
There we go.
For built-in display.
My hero. Thank you very much. All right, now we can do the demo. So what I'm going to do here is, first of all, I'm going to run your Cassandra process. This is an empty database. I just deleted the data folder, so it's completely empty here. Let's wait for a bit. This is long. All right. Yeah, takes a while. So meanwhile, what I will also do is, this is the Sidecar process that will be running. Let's see if this ready in. There we go. The default super user was created. So now we can run this Sidecar. Yeah, it's initializing the table. So meanwhile, what we can do here, it's running the. So this one here is the Cassandra client. It's just a SQL/SH plain client. And what I'm going to do here is running a Kafka consumer that I have reading from from a local Kafka Kafka cluster that I have running with Docker in my laptop as well. So this should also, yeah, okay, this is done. Now what we need to do, let's create key space, CDC example, and let's also create a table. So So you can see this table. The important relevant parts are like, we only have a message ID, which is a UID and text. And then the CDC flag is set to true. So this is currently supported by Cassandra already. All right, we have the table. Sidecar is on. Now we need to configure Kafka, Sidecar. And to do that, I have a couple of cool API calls. So as you can see here, we're configured. These are two new APIs that we are adding to Sidecar as well. That will configure Kafka and CDC. CDC is specifying the name of the topic and the data center, environment. And then the relevant parts here are basically, yeah, we're pointing to local Kafka using string serializer for the key and byte serializer for the value. Let me do that. All right, those has been run. Now we can see them on the log. And what's happening now is that Kafka identified that there was a configuration change. So it just restarted the CDC iterators. There we go. As you can see, Sidecar is calling other sidecars for actual segments for the CDC. Now, what will happen here if we do an insert, hopefully, is let's do a hello world. Now it may take a couple of seconds because, you know, it's only my laptop, but there we go. So this is the message that we consume from the Kafka topic. Has a timestamp, key space, what type of operation it was. It was an insert. Yeah, the dated fields, and what was the actual thing. Let's make sure that I'm not cheating. There we go. It worked. All right. That was it. Thank you. Sorry? Oh, yes.
He doesn't trust.
Making it hard, right? So this message ID, let's copy paste it. I'm not going to write it. Of course, because table name is not an actual table name. So it's CDC example dot I'm crossing fingers. This is off. There we go. Yeah, that's probably a bug, but yeah, we got the event. All right. There's that.
Are you taking any questions now, or?
I guess
Yeah,
so.
we do.
Yeah, we have 3 minutes, I think.
One quick one, like, yeah.
Steve?
Oh, yeah, Mike.
Sorry. don't.
I was curious about the, like how is you as the operator decide how many sidecars to install? Because it seemed like, at least from your diagram, that not every host has a sidecar on it, but like somehow you're deciding like, you know, one host has a sidecar that represents these collection of hosts. And is that true, or did I misinterpret how that configuration
No,
is?
you did not. So the way we have been running it is we have one sidecar per Cassandra node, but that's a choice that we made. Technically, there's no need for you to do that. You can even like run different sidecars for different things and have these sidecars specialized just to deal with CDC. So that's something possible as well, because you need to actually enable CDC on the sidecar process when you configure it to run it. The way it works is that right now every sidecar will take lead on a token range. So you know you have less sidecars, token range will be wider. Now, you are bound here by, I would say, CPU, because serializing on Avro is expensive. That's the expensive part.
Okay, cool. So they negotiate with themselves?
Yes, yeah.
Oh, okay, that's very cool.
Like there's some room for improvement there though on the actual implementation, and that's so we wrote the interfaces, and that's probably something that the community will be able to jump in and help to improve that, because right now it's, I won't say dumb, but yeah, right now it's pretty dumb how that is being done.
Thanks.
Hey, thanks for the presentation. I had one question about the architecture that you presented at some point on CDC.
This one?
Yes, this one. So given this current architecture, right, how does the sidecar is not introducing a potential single point of failure? If so, are there plans to replace or maybe refactor that part? Additionally, what are the implications of this design in terms of defining your service level agreements?
Mhm. That's a lot of questions, but let me try to go through them. So go ahead.
Yes, the first part is the sidecar not a single point of failure? If no, why?
Mhm. So as I mentioned before, you can choose to run as many sidecars as Cassandra nodes, and the sidecars, what they're doing is that they're pinging each other, and they detect when one of them fails, and another sidecar will take over that token range. That's how we get resilience.
I see. And the second part is how are you defining your SLA basically?
Sorry.
How are you defining your service level agreements in these kind of designs?
So for that, in terms of resilience and availability, given that we run a process alongside every single Cassandra node, we keep the same SLAs for that. Now, in terms of how long would it take for a message to get to the production, to the consumer, that's we're still working on that. We don't have numbers because we haven't worked with this at like huge scale yet. But it will also depend on the transport layer and your potential Kafka latencies.
Do you
So
have
we-
do you have some metrics or something to
So
like?
the test that we have been doing is that for P99, we have under 3 seconds.
Okay, thanks.
So currently it shows the latest information in the Kafka. Do you have any plan to show before and after if somebody wants or like interested in knowing what was the state before the change? Thank you.
That's definitely a hot topic. And it's a limitation on how CDC is implemented for Cassandra at this point. The reason being, as I mentioned before, the only thing you're appending to the commit log is the delta. If you want to produce the entire row, you need to do a full read. And a full read means potentially reading from different SS tables. And that would be adding a read for every write to your database, which is not a cheap operation because you need to construct the row. We are thinking a way of mitigating that, but yeah, it's not a simple problem to solve. So I don't have an answer for that yet. All right. Thank you.